Most icebergs appear white or blue when floating in seawater because ice absorbs more red light than blue light. But ever since the early 1900s, explorers and sailors have reported seeing curiously green icebergs around certain parts of Antarctica. And these icebergs aren't just a little green, they're really green. The ice is often a deep emerald hue, much darker and clearer than that of normal icebergs. So what's responsible for the unusual color? Scientists got their first clue when a group of glaciologists took a sample from a green iceberg off the coast of the Amory Ice Shelf in 1988. They found the green-tinged ice was different than normal iceberg ice. Icebergs break off of glaciers and ice shelves that flow into the sea. This glacier ice forms when layers of snow build up and solidify over time, so it naturally has air pockets that reflect light. But in Antarctica, some icebergs have a layer of what's called marine ice, ocean water that has frozen to the underside of an overhanging ice shelf. We can only see marine ice on the ocean's surface if the iceberg capsizes. Marine ice is clearer and darker than glacier ice because it doesn't have any air pockets to reflect light. When scientists analyzed the iceberg sample they took in 1988, they found the green ice was made of marine ice and not glacier ice. They suspected some impurity in the ocean water underneath the Amory Ice Shelf was turning the ice green. Their first thought was that dissolved organic material from long-dead marine plants and animals was getting trapped in the water as it froze. Dissolved organic material is yellow, so if pure ice is blue, the addition of yellow particles could turn it green. But when researchers measured how much organic material there was, they found green ice had the same amount of organic material as blue ice, so that couldn't be what was turning the ice green. Scientists puzzled over the problem until a few years ago, when an Australian oceanographer tested an ice core from the Amory Ice Shelf for its iron content. She found marine ice at the bottom of the core had nearly 500 times more iron than the glacial ice above. Iron oxides found in soil, rocks, and common rust tend to have warm, earthy hues, yellows, oranges, reds, and browns. So glaciologists began to suspect iron oxides in the marine ice could be turning it green. But where was the iron coming from? As it turns out, the answer didn't come from the sea, it came from land. As glaciers flow over bedrock, they grind rocks to a fine powder known as glacial flour. When the ice meets the sea, this glacial flour flows into the open ocean. If the fine rock particles become trapped under an ice shelf, they could be incorporated in marine ice as it forms. Glaciologists now suspect iron oxides in glacial flour from Antarctica's mainland are responsible for creating the stunning emerald icebergs. If their theory proves correct, green icebergs could be more than just a curiosity. They could be important for sustaining ocean life. Iron is a key nutrient from microscopic plants that form the base of the marine food web. But iron is scarce in many areas of the ocean. If the scientists are right, it would mean green icebergs are ferrying precious iron from Antarctica's mainland to the open waters of the Southern Ocean, providing this key nutrient to the organisms that support nearly all marine life.